Multiplicity. So multiplicity is simply a fancy word, but it's really not a fancy meaning. It just means your degree. That's the degree of the factor. Okay, because we have two zeros. We have a 0 at -2 and we have a 0 at +4. For my first factor, when you flip the sign, instead of x minus 2, what's going to go here? X what? X plus 2. But because the multiplicity is 2, this factor is really squared. That's what that means. So we really have the factor x plus 2 twice. That's what multiplicity of 2 means. Okay? And then we have another 0 at +4. So what would be my factor? X what? -4. Now that one has a multiplicity of 1. And when you're finding your degree, you always add up your exponents. And when we add 2 plus 1, what is my degree? Does it equal 3? Yeah. So we know that it is a third degree. If we did not put that 2, then that would make it a second degree function. So one of them needs to be doubled. And for this example, it would be the +2 factor. Jasmine, did you have a question?
Yeah, why every time parentheses and we multiply them, you switch the sign?
Okay, so that's a good question. So if we have x plus 2 equals 0, what would x equal? So in order for me to get a 0 at -2, my factor has to start off with the opposite. Okay, so if I set this equal to 0, my factor, and I solve it, the only way, if I put an x minus 2 as my factor, when I solved it, would x be +2 or -2? So that's why you have to flip the sign when you're writing your factors. Because remember, that's what we get before we set it equal to 0, before we solve it. All right, so now we need to multiply these out. Now keep in mind, though, that you really have this one twice. So it might be in your best interest to write it out twice. All right, so we're going to start off by, you can make a box and multiply these two together. So go ahead, make a box, multiply x plus 2 times x plus 2. Eventually. That's in 4.2. In 4.1, we just write our equation. But when we get to 4.2, which we'll probably get there Monday or Tuesday, I'm not sure, then we will graph it. All right, so we got a 2x, and a 4. So when I combine my like terms, I have y equals, and then that would be a x squared plus 4x plus 4. And let's carry down this x minus 4. So now we need to multiply these together. Now I make boxes. Now you do not have to do that. If you want to use the distributive property, you know, or FOIL, that is fine. Boxes, for me, I just find that most students find it a little easier because their like terms are at a diagonal, but you do not have to make a box. So I'm going to make a second box. In my second box, I'm going to multiply x minus 4 times x squared plus 4x plus 4. All right, go ahead and fill in all 6 squares and combine your like terms.
We have to carry down the exponent of 1.
Where is the exponent of 1? You mean on the x minus 4?
Yeah.
I mean, you can, but you don't have to. So the reason why we put it on the x plus 2 is so we knew we had to write it twice. But after you do that, I mean, every term has an invisible exponent of 1. It's like saying 1x. Do you have to put the 1? But now it will be. It's still going to be a degree of 3 because this one has a degree of 2. And then this has a degree of 1. And 2 plus 1 is 3. Yeah, remember, degree is your highest exponent. All right, so let's go ahead and fill in all 6 squares. This is what we're doing in integrated. All right, make sure I fill them in right. We all agree with my terms. So again, the only reason why I like it, you know, the box is a little bit more work, is because my like terms are at a diagonal. So that's why I personally like the box. So when I take it out, I have y equals, and then I have my highest power. Now when I add these together, what's going to happen with my x squareds? They're going to cancel. So you don't have to put it. You can put 0x squared if you really, really want to. Or we can just drop the x squared altogether. Now let's look at our x. When we add these together, negative 16 plus 4, negative 12x, and then minus 16. And that would be your final answer. All right, any questions about how we work through that and what the word multiplicity means? So when you see that, you're going to write your factor, and that just means that whatever that factor is, we have that factor twice. Yes?
So what's that?
What I have circled at the bottom. Let me highlight it. So this is our equation. Yeah, this is our, so we had to do 2 steps. We had to do 2 boxes. So our final answer is this equation right here, y equals x cubed minus 12x minus 16. If we had a graphing calculator and we typed it into Desmos or, you know, some kind of graphing calculator, this would have, it would hit negative 2 and it would hit positive 4, and it would be an odd degree. Yes.
Will we ever have to like go backwards? Like go from, you give us like the answer, and we have to go all the way back to?
Yeah, that's at the end of chapter 4. Yeah.
Oh,
Yeah.
looks like I'm gonna cry.
I know. Chapter 4 got a lot in it. It do. We start off with the easiest things and then we kind of, you know, back it up. Go ahead and copy down this next one. Do we have to do that?
Right, that's odd.
No. All right, so I'm gonna give you a couple minutes to set up your factors. I'm gonna come around and look at what you write. So we have a 0 at positive 5, and that has a multiplicity of 2. We have a 0 at negative 1, and that has a multiplicity of 1. So.
So degree. So this is degree.
The degree is the degree is telling you what your multiplicity is. So it's odd. So we have no side. So if it was 4, if it was 4, we would have a multiplicity of 2, multiplicity of 2 another side.
Because it added both of those.
Yeah.
Am I supposed to be signing those? I didn't say anything. That's kind of crazy. Cheers, John. I didn't say anything. What's your problem? Thank God. Leave me alone. Going for degree. Did you solve it? Are you solving it?
Did you say something?
Yeah, what'd you get for the first box?
But that's what the exponent is adding to.
Oh, they both add.
So you should have 2 factors. So what would be your 2 factors that you're going to start off with? Y equals
X minus 5.
x minus 5 squared. And then what's your second factor? X plus 2. So here was the mistake on chapter 2 tests. You cannot do this and say that it's x squared plus 25. If you're trying to square x minus 5, there should be 3 terms. So if you don't know the pattern, I'm not gonna make a box, but go ahead and make a box and multiply your x minus 5 times x minus 5. And then whatever you get, that's going to be the answer that you multiply by x plus 2. So did anyone already multiply x minus 5 times x minus 5?
Yes.
Anybody want to share what they got? All right, good. So y equals, y'all sound like a little choir, x squared minus 10x plus 25. But we're not finished yet, because when we're done, our final equation should have a degree of 3. So we got to take that answer and multiply it by x plus 2. So I'm going to make a box. I always make a box when it's a 2 by 3. I don't make it when it's a 2 by 2, but a 2 by 3, I just like to make the box. Making the box?
No, if you like distribute it.
Yeah, if you distribute, I just like it to be organized. So that's why I like to make a box for it, but not, I think, it's whatever you prefer. Again, I'm just looking for the right answer. Okay, so in this first square, we got x to the cubed, or x to the third. Then we have negative 10x squared. And then positive 25x. The second row, I have 2x squared minus 20x plus 50. So my final equation will be y equals x cubed. And then we're going to add these together. And what do you get when you add that? What would be your quadratic term or your x squared term? Negative 8x squared. And then we have our next one, which would be these two. Positive 5 or negative 5? Positive 5 and plus 50. And that's it. Simple, right? Nothing complicated. Okay, let's keep moving. So now we're going to talk about, for questions 60 and 65 in your homework, we have to answer all 4 of these questions about the equation, okay? So I'm going to give you, if you want to copy this down, but this is again straight from your book. So I just wanted to word it the way it's worded in your homework. So when you see it, you're not like, what are they asking me to do? So I'll give you a couple minutes and then we will go through these together. So we have to list the 0, the multiplicity. We have to determine if the graph is going to touch or cross, and I'll explain what that means. We have to figure out the maximum number of turns on the graph. And we also have to write the end behavior. So I'll give you a minute to copy that down and then we'll work through it together. Okay, so for the first one, it's asking us to list the zeros. So in order to list our zeros, we start off by setting our factors equal to 0. So this is a factor, and this is a factor. So when I set x equal to 0, I get 0. There's nothing to solve there. But when I set x plus 3 equal to 0, what do I get? Negative 3. So for part A, it's asking us to list each 0 and the multiplicity. So this first one, what is the exponent on x? It's invisible.
1.
So that means that it has a multiplicity of 1.
Which means I, right?
Yes, and we'll talk about what that means in a second. And then for the second one, one second. And so for the second one, x equals, because this is my exponent. So for my second factor, my exponent is 2. So my multiplicity is 2. So what does that mean exactly for a graph? Anytime you have an even multiplicity, that means that on the graph, it is going to just touch or bounce off the x-axis. So for example, and I'll make a little sketch. I'll sketch this one so you can kind of see what I'm saying. But if you have an odd multiplicity, instead of it bouncing, it's going to just go through at that point, or cross. So for part B, so this is the answer to part A. So for part B, does it touch or cross? Well, at 0, 0, because the multiplicity is 1, it's actually going to cross through the x-axis. But at negative 3, 0, it's not going to cross. It's going to touch or bounce. Part C says, what's the max number of turns? And when I do my sketch, it'll make this all kind of come together. My max turns is always your degree minus 1. And to find your degree, you add together your multiplicities. So if I add together my powers, 1 plus 2 is what?
Sweet.
That's a third degree. So this is a third degree. And the max number of turns is always your degree minus 1. So the max turns that this graph will have is 3 minus 1, which is 2. So there's only 2 turns that are going to happen. So now let's talk about our end behavior. So the left side, as x approaches negative infinity, f of x approaches. So if you look at that handout that I had you glue down yesterday, we need to figure out what is going to happen on the ends of this graph. So the first thing, we already said it's the third degree. So what do we know about third degrees? Do the ends do the same or the opposite?
So they do opposite.
They do the opposite. Now look at this 3 in front. Is that 3 a positive or a negative 3? It's a positive 3. So this is a positive odd function. And when it's positive and odd, this is what your end behavior looks like right here. Okay, on the left side, it's going to go down, and on the right side, it's going to go up. The right side always does whatever the sign of this is. So because this is positive, the right side is going to go up. The left side is going to go down. So I think before we do B, this will all kind of make sense if we do a little sketch so you can kind of see what this is saying, and then we'll talk about B. So the first thing, we already know that it only crosses the x-axis where? What do we say for part A? Where are my two x-intercepts going to be? For part A, where do we say our x-intercepts were? At 0 and where else? -3. So I'm going to put like a point at 0. And then I'm going to put a point at -3. 1, 2, 3, 4. Put a point here. Now we already know that according to my end behavior, what is going to happen on this far right 0? From this point, is it going to go up or am I going to draw an arrow going down on the right? It's going to go up. And then on this side, what is it going to do? Is it going to go up or is it going to go down? It's going to go down. So at the 0, because the multiplicity is 1, at 0, it's just going to, right here, it's going to go through. But at -3, it's going to bounce. So what I mean by that is the graph is not going to go through here. It's going to hit it, then it's going to turn back away, and then it's going to come through at the 0. That's what it's saying when we say touch and bounce. At -3, our graph is not going through it. It like hits that 0 and bounces back down. But then at 0, it actually goes through. Now, how many times did this graph turn? Twice. A third degree can only, the maximum number of times it could turn is twice. So we have 1 turn and 2 turns. The max number of turns is always 1 less than the degree. All right, now that I have got through that full example, what questions do you have before we look at the second one? Does it all make sense? Kinda? No? A little bit? All right, we're going to keep practicing because that's what we do here. We learn. And
If there's 2 turns, where are the second turn?
oh, sorry. I'm glad you said something. It was almost deleted. So I'm going up. See, I made a turn.
Oh, okay.
Then I made another turn. Does that make sense? Okay. All right, so now let's look at the second one. Let's go ahead and copy that down if you haven't already. We're going to answer all the same questions again. So a factor has to have an x. This -2 does not count as a factor because it doesn't have an x to go with it. So we have 2 factors that are going to determine my zeros. I'm going to set this one equal to 0. And I'm going to set this one equal to 0. So I have one at +2, 0. And I have another one at -1, 0. Both of these have odd multiplicities, which means that it's going to go through for both of these. So we have a multiplicity of 3. And we have a multiplicity of 1. All right, so part B, both of these are going to cross through because they're both odd. So it's going to cross through at both of these points. What's my degree for this one? If you add up your multiplicities, what do you get? 4, because I'm adding 3 plus 1, which is 4. So this is a 4th degree, which means the maximum number of turns I'm going to have is what? Max. That doesn't mean I have 3. That means that's the most I can have. You can have less than 3, but you can't have more than 3. You okay, Genesis? Genesis, she okay? Oh, okay. Make sure it's all right. All right, so now let's talk about our end behavior. Yes.
How is it max 3 turns?
So your maximum number of turns is always your, whatever your degree is, -1. That's the maximum number you can have. And because 4 minus 1 is 3, 1 second. Then let me do the next one. Then I'm going to go back to questions. Okay, so then let's talk about in behavior. So this is an even because 3 plus 1 is 4. Is this even in positive or even in negative?
Even and, wait, no.
Negative.
Negative because of that 2.
Yeah.
So what does that mean about my arrows on both
Yes,
sides?
go down.
They're going to both go down. Yesterday, I wrote it as 1 in behavior, and I feel like that was confusing. But again, anytime it's even, you can save a step and write it as 1. But both sides are going to go down. So if we were to sketch it, this is actually going to look like a parabola, even though it's a 4th degree. So we have x-intercept at positive 2, so positive 2. And we also have one at negative 1. So we know that both arrows point down, so I always like to put my zeros here because on Monday or Tuesday, I'm not sure when we will get to it, we're going to graph them. But what I always tell my students to do is put down your zeros. The 0 on the far left, what am I going to do with this arrow off negative 1? Am I going to have it go down or up? Well, yeah, we already established it has to go down, and it's going to go through. Now, it's probably doing something up here somewhere, but it doesn't come down far enough to ever actually touch the x-axis except at those 2 places. All right, now that we have those complete, what questions do we have? Yes. Oh, so you would just say x is approaching plus and minus negative infinity. And then y approaches negative infinity. That's if you wanted to. You could just say plus minus instead of. Wait 1 second. Over here next. I think I saw Lauren's hand up. I didn't. Did I see a hand up over here? Okay, I was playing. Sorry, my bad. You.
So for the in behavior stuff,
Mm-hmm.
I kind of get confused with the x, like when x is going to negative infinity.
Mhm.
Can you just go over that again?
Yep. And so x is negative on the left side of the y-axis. X is positive on the right side of the y-axis. So this is the left side. This is the right side. So it's asking you on the left side of the y-axis, what is the arrow doing? Yeah. So one thing that I like to think of is whatever this says, this tells me the right.
Mhm.
And if it's even, the left is going to do the same thing as the right. Good questions, y'all. Good questions. We got time. So. All right, we got one more. And then we will end there. So we're going to write an equation in factored form. So we know we have to write it in factor form, which first of all means I don't have to multiply it. If it's in factor form, we don't have to multiply it. No multiplication. So we don't have to make boxes. We're going to just leave it in parentheses. That's what that form means. So this way it's a lot easier, I guess I would say. So my dad is coming in town tomorrow to watch the Bears play the Colts. I guess they don't play every year, so it's a big deal.
No, they don't.
Yeah.
I think my dad's going.
But why? Why don't they play every year?
I mean, one's the AFC, one's the NFC.
Okay. I don't know much about football. So I guess it's a big deal. So yeah, he coming down. Sorry. Okay, keep working, y'all. So we got 3 zeros. So we got 3 factors. We got a factor here. This one gets a factor. This one gets a factor. And the reason why they gave us a point is so that we can find the A value. If we don't have a point, then we don't know what our A value is. We know our factors, but we don't know our A value. We have to know at least 1 point on the graph in order to find the A value. So let's start off by writing our factors. So we have y equals So for my first parentheses, what am I gonna put inside? Instead of a positive 4, I'm gonna put but actually, let me back up a little bit. So because we're trying to find our A value, so I want you to put y equals, and then we're gonna put the A right here, because we have to find that. So I'm gonna make a little bit more space. Sorry about that. So in the first one, we have a -4. What about the second one? And the third one? All right, so we don't have to multiply them because it said factor form. But now we need to find A. So in order to find A, we're going to use our point and substitute it. So this is X, this is Y. So every place where we have an X, I'm going to put that 6. I'm going to put a 6 here, here, and here. And then where I have my Y, I'm going to put that here. And we're going to solve for A. So then that gives me the equation 180 equals A times, then it's 6 minus 4, 6 minus 1, and 6 plus 3. So I think the easiest thing for you to do would be to figure out what is this number. So we have 180 equals A times, and that's a 2, a 5, and a 9. What do we get when we multiply 2 times 5 times 9? 90. So that means 180 equals 90A. So and then to find A, what would I have to do? So what is my A value?
2.
So we have a third degree with a positive leading coefficient. So our equation that all you have to do is go back to the beginning and rewrite it one more time. And this time, instead of putting an A, we're going to put what A actually is. So my final equation would be 2 times X minus 4, X minus 1, and X plus 3. All right, questions about that?
No,
Okay, so we're going to end there. Just to kind of set us up for success, though, on Monday, I am going to have you glue down the graphs for Monday today so that we don't have to waste time on Monday pulling out glue sticks.